Good afternoon and welcome to the NBCO's spring series of webinars. I'm Éine O'Keneela and I manage the National Building Control Office training. We work with building control authorities, owners, designers, builders and suppliers of construction products to promote compliance with the building regulations. Product suppliers have a vested interest also in ensuring that their products are used correctly in the construction process and not damaged in the process. And where we find damaged or misused products during our site visits, we are now informing suppliers and manufacturers of these products, who in turn are encouraged to promote compliance through education and training in the correct use of these products in buildings. The mission of the National Building Control Office, or the NBCO, is to promote a culture of compliance with the building regulations in an industry marked by rapid changes in technology and processes. We do this through 5 pillars: compliance support, education and training, what we're doing today, inspections, our BCMS system on localgov.ie, and market surveillance of construction products. The building control legislative framework within which we work includes the Building Control Acts 1990 to 2014, the Building Control Regulations, the Building Regulations Part A to M, the European Union Construction Product Regulations, and associated market surveillance, and the European Union Energy Performance in Building Regulations. To promote compliance with the building regulations, we support building control officers in 31 local authorities who are continually inspecting for compliance with the building regulations and the building control regulations. Inquiries can be made to the relevant building control authority or ourselves in the NBCO at support@nbco.gov.ie or to the department at buildingstandards@housing.gov.ie. We have a number of events as outlined. Live events will be circulated with Eventbrite, and recordings will be on the NBCO YouTube channel. I would ask that you use the question and answer function throughout the webinar, and the Q&A will be provided under the video description on YouTube. I will now hand you over to Tom Meehan from Ei Electronics, who will speak on the fire and carbon monoxide detection and compliance with Part B, J, and D of the building regulations. You can stop.
Okay. Okay, you can see that, yeah?
Perfect, Tom. Thank you.
No bother. So we're just going to go through a brief history of the standards and the regulations, where they came from. We'll do a bit then on the sensors and the technologies that are available today to comply with the building regulations. We'll go through some of the standards and the regulations themselves. And then we'll go through into what's available in the future, what's coming down the line in relation to how we're going to tie everything into the famous Internet of Things. Okay, so just to start off, I suppose, basically on the standards and regulations, when they came into play in Ireland was in 1997 under Technical Guidance Document B, and that referenced the BS 5839 Part 6. Then we moved on in 2009. We developed our own standards in relation to residential detection. under IS 3218 Part 9. In 2013, again, there was a refurb of IS 3218, and it was moved out to Part 10. And then in 2017, technical guidance documents, it was the first time technical guidance document B referred to the IS 3218 standard, which brought our own Irish standard into play here, and that's the Part 10, and that's where we're at the moment. So if we look at year 1997, what was required at that stage was a smoke alarm in the hallway, a smoke alarm in the landing, and a heat alarm in the kitchen, and that was basically it. And that was, again, as I said earlier, covered by BS 5839 Part 6, same reference. In 2006, we looked at Part B again, and that was upgraded, and they added the principal living room into the equation at that stage. You know, we moved from three devices up to 4 devices in 2006. The next review that came was in 2017. And at that stage, we could now reference the IS 3218 standard, Part 10, which was the first time this was available, because prior to that, in 2006, the IS 3218 standard wasn't available. So when you look at this in relation to the way the standard has moved from 2006 to 2017, we look at the installation, and you can see from the graphic there that there's a high density of smoke detection and heat detection within the premises itself. So what they look for at that stage is interconnected self-contained mains-powered battery backup, smoke and heat alarms as per grade D. And they're to be located in all circulation areas that form part of an escape route within the dwelling, and in all high-risk areas and rooms, for example, kitchen, living rooms, garages, utility rooms, and all bedrooms. So all bedrooms was now in the equation at this stage. I suppose that there are a couple of reasons why all the bedrooms were brought into the equation on this particular time, and that was because 2 things. Basically, we want to get the sound pressure level up to 75 dB at the bedhead within the bedrooms themselves, to equate with the commercial side of the business, where they have the 75 dB at the bedhead for quite a while now in commercial premises. So that was one aspect of it. And the second aspect of it was the rate of fires that were happening in bedrooms was gone to a very high level. It's at over 34% of fires now start in bedrooms. And that's, I suppose, down to a lot of the technology that's been used within the bedroom itself. And you'd have chargers for phones, tablets, laptops, you have TVs, you have PlayStations, all that type of technology is within the bedroom itself. And it can give trouble from time to time. All you have to do is look at some of the graphics that are coming out from many of the fire services around the country in relation to charges and that, and it does create quite a bit of damage and some loss of life as well, unfortunately. But yeah, over 34% of fires now start in the bedroom area. So that was one of the things they tried to overcome from the point of view of smoke detection in there. So again, going back, we didn't change anything on the grade of system. The grade would still remain mains powered with battery backup. Now the battery backup on the smoke detectors can be either the alkaline replaceable battery backup, which is the PB3 9-volt unit, or it can be the rechargeable lithium cells. And the rechargeable lithium cells are mounted on the PC board. It's a sealed unit. It can't be taken in or out of the unit for any other purpose. So it's a more secure, I suppose, device in relation to getting units on the ceiling and keeping them there without getting or having the batteries being taken out for use in remote control for kids' toys or TVs or whatever the situation is from that point of view. So they're the 2 types of battery backup. And I suppose from a local authority point of view or a housing association point of view, from a landlord with the duty of care from a tenant's perspective, the most used device would be the one with the rechargeable battery backup, because that's perceived to be the higher quality and would more than likely be left within the unit itself. Okay, so we'll move on to the different sensor types in relation to the installation themselves. And this will equate, once we get the sensors, the information on the sensors out, it will equate to the graphic you saw earlier in relation to the design installation from the IS 3218 standard. So we'll first of all have a look at the optical sensors. The optical sensor, I suppose, historically has been the less used of the smoke detector for the simple reason it's a bit more expensive to manufacture over the ionization type, but it's probably the more stable type to be used in residential premises. And again, we'll see this from the color and the graphics later on in relation to the location of these devices. It's more than likely the device of choice within the premises at this stage. So if we just look at the sensor itself and how it operates, what you have on the top of the unit itself is a light source, an infrared LED, and that pulses a beam of light into the chamber every 10 seconds. At the bottom right-hand corner on the southeast, you can see the light receiver is a photodiode, and that's, I suppose, shaded and kept away from the light source in normal circumstances. If we just look at here and the pulse been sent out, those yellow sections will represent where the light will transmit around the chamber itself. You can see from the light receiver, it hasn't hit that area yet because it's protected by baffles within the chamber. So we're just looking at reflective sources at this stage. So we'll introduce a bit of smoke into the chamber, and you can see from here, there's smoke into the chamber. What we're looking for at this stage is an increase of smoke density. We're also looking for two different things here. We're looking for obscuration levels. So we want the beam to be obscured at a certain level. Under the standards, we have to manufacture the device at obscuration level between 2 and 4%. The device has to activate at that stage. And we're also looking at the light scattering principle, which, if you look there, there's no beam of light going into the light receiver. But once you get a high density of smoke, you get what they call the light scattering principle, and that scatters beams of light all over the chamber, and eventually you get a beam of light going into the receiver. That closes the circuit and sets the unit into alarm. Okay. That's the basic operation of the optical unit. Okay. So the ionization, even though it's still a smoke alarm, so these are the two different types of smoke alarm I have. We have optical and we have ionization. The ionization sensor works in a totally different manner than the optical unit, even though, as I said, they're still two smoke alarms. So I suppose the optical unit is looking for the thicker black smoke. So the likes of furniture, materials, anything like that, timber, anything within the premises itself, it more than likely gives off the thicker black smoke. So it's probably, that's why they look for it as the most ideal sensor to be used throughout the residence. If you look at ionization sensors, again, as I said, they're smoke alarms, but they work totally different. We have a radioactive source within the chamber itself. It's americium-241 is what we use. And we have two sensing plates and the smoke entry slots at the very bottom of the chamber itself. And what happens here is that it detects the ionized particles produced by a fire. Now, that's fine if it's a fire situation, but the biggest problem with ionization detectors is that you get ionized air from ovens, from grills, from toasters. It's the same air, ionized air that's produced by those appliances. So if you have an ionization detector near a kitchen area, you're going to get false alarms. Okay. So the radioactive source then ionizes the air between the two sensing plates. The smoke entering the chamber attaches to the charged ions. That creates a drop in current between the two sensing plates, which in turn triggers the alarm. So that's it. So it's a chemical reaction that takes place within the chamber itself, unlike the optical unit where it actually is breaking a beam of light. Okay, the heat sensor. The heat sensor has a fast response thermistor under the cover of the unit itself. And in recent years, we have reduced the diameter of that thermistor itself, which now gives us a faster response to the increase in temperature. And if we look at that, it detects the change in temperature from a fire. Heat passes over the thermistor, and we have to set, again, under the standards, we have to set that at between 54 and 62 degrees. So we trigger that thermistor at 58 degrees C, and it only responds to heat and not smoke. We do get a lot of calls into the office in relation to the heat alarm in the kitchen going into alarm. It's more than likely that the customer, the tenant that's in the kitchen, but something that's happened within the oven or the grill or whatever it is, and set the ionization detector that's outside the kitchen door into alarm. And the fact that they're all interconnected, that's the unit that they're standing under, and that's the unit that I think is after activating the system. But I can guarantee you, they wouldn't be standing in the kitchen if there was 68 degrees inside there underneath that. So it's more than likely not the heat alarm that reacts to that. It's something that's triggered elsewhere. But the fact that they're all interconnected, as I say, would give that impression to the ordinary tenant, the ordinary person that's not au fait with the system. I've put carbon monoxide in sensors in here just because we're doing the sensor type of it, but it's something that we'll cover later on. There are a couple of things that you might just keep in mind when we go through this in relation to, especially the location of the devices later on. It might clear up a few bits of misinformation that are out there in the field. So what you have here, it's a bit more intricate than the smokes of the heats. We have that the CO sensor itself, and we just covered that with a green cover them just to give a bit of extra identification on it. But if you look at the middle of that sensor, green cover, you can see the small little hole, and that's the aperture that the carbon monoxide goes through. And underneath that, you have a graphite filter, and that stops an awful lot of dirt and dust and fibers that are in the atmosphere getting into the chamber, so it won't distort whatever's going on inside there. Underneath that, then you have a couple of electrodes and counter electrodes. You have a wick material down there at the bottom, and that wick material is very important. That wick material has to stay at a certain moisture level. It's soaked in H2SO4, which is sulfuric acid electrolyte. And that has to retain a certain moisture level. If it doesn't, if it dries out, the unit will go into fault. And also if it gets overexposed to moisture, it will go into fault as well. So it's very important that retains a certain moisture level within the unit itself. And underneath that is where we get the expense on the sensor, I suppose, when you look at, because we have to use platinum and gold, and that's where a lot of the expenses comes into that. So it's a fairly intricate device, and it works in a lot different than any smoke detector. So again, it's a chemical reaction that takes place within this chamber or the sensor itself. So when it detects the carbon monoxide, that's the gas produced by carbon-based fuels. A chemical reaction occurs between the CO gas and the sulfuric acid. And this creates hydrogen ions, which gives off a voltage and a current flow across the electrodes. And that current output is proportional to the CO level within the atmosphere itself. So if that unit produces 4 microamps of current, that equates to 100 parts per million of carbon monoxide present in the atmosphere. So it's a very, very accurate way of measuring the atmosphere for carbon monoxide levels. We also have a couple of units which we introduced into the market over the last couple of years in relation to combinations of devices. So with the optical heat, it was there in this guise before, the multi-sensor, an EI2110. So what we have here is probably the best unit that is on the market at the minute in relation to detecting any type of fire. You have 2 sensors working together to provide a wide range of fire responses. The optical sensor will trigger from smoke alone. The heat alarm, the heat section will trigger from 58 degrees C. But there's intelligence built into the unit as well, and this is where it makes it probably the best unit on the market. If the heat sensor detects a rise in temperature, then the optical sensor becomes more sensitive. And I said earlier when we were speaking about the thresholds we have to manufacture the optical unit at, it's between 2 and 4%, and we automatically have it in the middle of that, and we have it at 3% is the threshold for the obscuration level. But if this unit sees a rise in temperature, that automatically drops from 3% down to 2%, which will make it a lot more sensitive. So we get the information about a fire situation a lot faster than we normally would. Okay. So that's another advantage of this unit. We have what we call dust compensation built into this unit. Dust can be a major issue from the smoke detection point of view because the chambers and smoke detectors I suppose, rarely differentiate between smoke and dust. It's still an obscuration level within the chamber itself. But we have put into these devices the dust compensation. And basically what you have here is you have a dust level, a basic dust level within, or a basic thresholds within the unit themselves, and that threshold has to be maintained as a constant. If you get a dust buildup in that, then the thresholds would get closer together, and that sets the unit into false alarm. But what we have done here is we have used a step-up situation which happens 32 times over the life of the unit. So if you do get a buildup of dust, in the bottom threshold, the top threshold actually moves at the same rate. So that constant is maintained over the life of the unit. Okay? So that's a massive advantage from that point of view as well. Just have a video here in relation to, I suppose, trying to get the message of this unit across a bit better. If you look at the left-hand side of the screen here, you can see it's a fire generating chamber that we have down in the factory in Shannon. There's 3 different sections there. You can see 3 different openings. So we're looking at from the top of the chamber down to the very bottom. And on the left-hand side, you'll see in a second where we generate a fire. Where we're looking from down at the top of the screen here, down into that chamber is where the smoke detectors are located. But if you look at the middle of the screen, we have graphs here which will show the temperature levels and also the optical obscuration level down at the very bottom. And of course, as you know, any type of fire will also produce a level of carbon monoxide. We're also going to measure and just have a look at this level of carbon monoxide that's produced as well during a fire situation. But I suppose the most important thing I want to do here is just to show you the temperature levels and the way when it sees a rise in temperature, the way the obscuration level, if you look at the bottom graph, that red line will drop from 3% that it's set at the moment down to the 2%. Okay, so just roll it there, Colette. So on the left-hand side of the screen there, you see that the fire being generated in this chamber here. We want to keep a close eye on this line up here with the temperature, and also this red line down here when the fire starts to generate a bit more smoke and heat. So if we look over here at the temperature levels, it's now increasing. It started off at 22%, it's now going to 27, 28. So we're getting an increase in the temperature levels within the chamber itself. And if you look here at the red line, it's now dropped from 3% down to 2%. So we're collecting our fire information a lot faster than we normally would. Okay, so if that gives a clear idea of actually what's going on within the sensor itself. So it's faster reacting than any other device on the market, and doesn't have any of the false alarms because of the intelligence and the dust compensation that's built into the unit itself. The next one we're going to have a look at is the Heat CO, and this is a nearly new unit, not long on the market, about 6 or 8 months. It's a combination of heat and CO. There's no intelligence built into this. It's just there are 2 separate sensors under the one cover, basically. Okay, so you have fire and sensor again with the threshold of 58 degrees C, and you have the electrochemical CO sensor, which triggers when there's carbon monoxide present. And both of these sensors are constantly monitored. Now, I suppose the perception out there is that the reaction for 2 different types of detection is the total opposite. For a fire situation, you seal in a room. For carbon monoxide, you ventilate a room. Okay, so it's very important that we have identification on the device as to which element of that alarm has activated. So we bring the element out through the cover. So if it's a fire, we bring the fire out through the cover, so it's a visual indication that the fire element of that device has activated the system. If it's CO, we bring the skull and crossbones out through the cover, so that indicates that it's carbon monoxide that's activated that device. Okay, again, it's very, very important. And also, what we'd always promote as well, if you are mixing the systems, mixing fire with CO, adding them onto the same system, you should also always use a control switch on the system itself, and that will just for example, if you have a control switch, that will indicate which device is activated by just turning off all the other units and just leaving the one unit that has activated the system on. Okay, that's the sensors covered, and we'll do a bit now on the standards and regulations. Okay, covering us on the standards and regulations for the fire side of the business, we have Power Technical Guidance Document B, we have the IS 3218 standard, we have the guidelines for rented accommodation, and I just threw in there the RTB's synopsized version of the rented accommodation, so which is a very good document as far as we're concerned. And then there's fire safety and community dwellings, which is not widely used at the moment, but it is, I suppose, in some areas. So if we look at the system categories, then the minimum level of detection within Ireland at the minute is LD2. And again, we spoke about this earlier. It's in all circulation areas that form part of the escape route within the dwelling. It's in all high-risk areas like kitchens, living rooms, utility rooms, and all bedrooms. So that's the minimum level of detection within the residential premises. If we look at LD1, there's very little in the difference. Only the any other rooms, I suppose, that haven't been covered, and that would include attics, lofts, and other spaces, which a fire must, other than toilets, bathrooms, and shower rooms. Again, they're all grade D, and these are for new builds, major refurbs, and rewires. So if we just look at the standard itself, and a dwelling house should be so designed and constructed that there are appropriate provisions for the early warning of fire, and there are adequate means of escape in case of fire from a dwelling house to a place of safety outside a building capable of being safely and effectively used. So there's nothing there, I suppose, about smoke detection, but you delve into the Part B itself and it'll give you a bit of guidance on it, and that also now refers to IS 3218 Part 10. And I suppose that gives you a lot more detail in relation to your installation and the locations and the type of devices that should be used. And that covers new builds, major refurbs, and rewires. So again, category LD2 is the minimum level of protection in the standard up to 3-story house. And this level of protection is applicable to individual dwellings with no unusual risk and with no floor area greater than 200 square meters. And where not a single family dwelling, it is intended to be shared by no more than 6 persons. Now, what I mean by that is you can't tell anybody how many people they can have in a single family. So you can have as many people if there's a single family dwelling and they're all in the one family. But if it's intended to be shared, it can't be shared by more than 6 persons. And if it's a larger dwelling than set out in 10.221 or higher than 3 stories, then category LD2 installation should be installed in each individual dwelling. And this is an interesting point. The next part is where the fire risk assessment determines that detectors shall be installed in the roof. So if we're going for an LD1 system, then a control switch should be installed on that system. Okay, so you need to allow for the functionality of alarm testing, alarm location, and alarm silence. Okay, so that's important from that point of view. So if you're installing in an attic space or in an area where you can't get to the test facility on the device itself from the ground area, whatever implement you're using, you have to use a control switch. That's your control switch there. That's the hardwired unit. As you can see, there's 3 buttons on it. The one on the left is a locate, then there's a test in the middle, and then there's a silence for the single device. So just for example, if you have 8 or 10 units in a house, one detects fire, sets off the whole system, you press the locate button. What the locate button does, it turns off the interconnect line, so all the other devices that didn't activate the system just leaves the one unit that activated the system on. Okay, if you go to that and if it's a smoke alarm, if it's a false alarm, you can come back to the device itself and you can now silence that unit if it's what you do in a fire situation. And the middle button is the test facility. So you can press that test button, it locks in position, and you can go around and make sure that all the devices on the system are working properly. Okay. So audibility of smoke and heat alarms. The audibility, I suppose, it's 85 dB at 3 meters is what we have to manufacture the units at. In the old way of doing it before we started putting smoke detectors in the bedrooms was we had to get 85 dB at the bedroom door, and it had to be within 3 meters of any bedroom door with the door open. But now the fact that we're putting in units within the bedrooms themselves, we're definitely getting 75 dB at the bed head. So it's still there in the standards, but it's a non-event really. There's also a recommendation here, 10.3.1 applies to many dwellings with limited sizes and straightforward means of escape. A higher level of sound pressure may be necessary if the occupants have a hearing impairment or other disabilities, and the provision of visual or tactile unit should be used in that situation. And again, you can go on our website to look at those. We have units for deaf or the hard of hearing that would have a flashing strobe, and a vibrating disc that goes underneath the pillow or the mattress. Okay, we say in our standards in 10.7 that smoke alarms should be tested every week. Now we do a lot of training around the country with different groups, and we ask this question: how many people have tested their smoke alarms every week? And we don't get a reaction. So yeah, it doesn't happen. But what we do find is the more the control switches are installed with the systems themselves, people are more inclined to test the system because of the facility of the test button on the control box. Okay, just I suppose an update on the BS standard. They've changed that recently from testing every week to every month. So as one guy said to us at the training session, so something we don't do 52 times a year, we don't have to do 12 times a year. So we're looking at it, yeah. Okay. Again, you can get a cert for the testing and maintenance of the systems themselves. Not widely used, but it's a handy thing for installers to use, and we're promoting that with the training we do with installers to use this and have a paper trail of their service and maintenance. So if we look at 10.8 of the Irish standard, it looks for at existing multiple occupancy residential buildings. We're looking at apartment blocks here, basically. For existing ones, where this came out of really was I suppose when we had the boom, we were building an awful lot of apartment blocks, and then suddenly the bust came and apartment blocks weren't finished. NAMA took them over, and then NAMA started to bring them to the marketplace again, but the standard of fire detection within those apartments wasn't up to the standards of the day or the present day standards. And you're now looking at a way of extending the system within the apartments themselves. Most of these were finished off, ready for sale. So the thought of surface wiring or mini trunking or whatever going across ceilings was a no-no. So they looked at the 10-year battery operated units with the RF interconnection. And this is what they came up with. Where buildings have inadequate or no detection, an alarm system or alarms are provided subject to adequate risk assessment by a competent person and subject to written communication with the local fire authority. Radio interconnected smoke and heat alarms, each incorporating a 10-year battery, may be employed in the individual dwellings only. Okay, so that's allowed, and that is a very big part of the business that we're doing at the minute in relation to upgrading of apartment blocks that were built back in the day. If you look at existing dwelling houses, what they're saying here in 10.9, anything built prior to the introduction of building regulations where it didn't require mains powered units, they say now the best installation there, if you want to put in just a fire alarm detection system, is the 10-year battery operated radio interconnected smoke and heat alarm. Again, Annex J would just give you, I suppose, a summary of what we're after talking about there. There is one part of it here. The living room and kitchen are contained in one single apartment. A heat alarm should protect the cooking area, and a multi-sensor or optical sensor should protect the living area. Now, that's a bone of contention out there at the minute. We see it a lot ourselves. We get a lot of calls about this. So our advice on that is a heat detector covers the kitchen area, and either a multi-sensor or an optical unit would cover the dining room or the living area. Depends on what they're calling it. So again, that's just a graphic of Annex J in relation to what's recommended under the IS 3218 standard. You get an option there in the bedroom area, and the reason the option is there is en suites. Just for example, an ensuite. If you have an ensuite in the bedroom, you're better off using ionization. If you don't, you're better off using optical. But the one thing I'd say about ionization, they're probably on their last legs at the minute. They will be phased out over the next period of time in the not too distant future. Most of our competitors at the minute don't supply an ionization detector because of the radioactive source. It's an environmental thing. There's licenses involved. There's extra costs in relation to transport. All that kind of stuff is going on as well. So we're looking at phasing out the ionization type detection. If you look at our new 3000 series devices, we don't have an ionization detector there. We do have a multi-sensor, which is replacing that. Okay, so that's standard housing done. We'll just have a look at the rented accommodation. Again, as I say, this is the RTB document that was sent out to all the landlords in the country in relation to what's required from their perspective in relation to rented accommodation. So Each house shall contain a suitably self-contained fire detection alarm system. Each house shall contain a suitably located fire blanket. Each self-contained house within a multi-unit building, so again, we're looking at an apartment block there, or converted 3-story, 4-story house that has apartments, shall contain a suitable fire detection and alarm system and emergency evacuation plan. A suitable fire detection alarm system shall be provided in common areas within the multi-unit building. So the landlord area is a separate entity to the apartments themselves. And each emergency lighting shall be provided in all common areas within the multi-unit building. And those systems should be maintained in accordance with the current day standards. That's basically what it's saying here. Just look in, and what they're talking about in a single house, what they're looking at, the minimum detection there in a single rented accommodation is a unit on the ground floor hallway, or if it's an open plan design in that area, in that room, and each upper floor landing of the stairwell. Smoke alarms can either be mains with battery backup, or they can be the 10-year self-contained battery operated units. If we look down at section 4 here, and this is where a lot of the, I suppose, property management companies, housing associations, local authorities, there will be the larger landlords within the country itself. What we're saying, what the SI 137 is saying here is each smoke alarm should be in working order and be within its end of life indicator. Now, if you have a housing stock of 26,500 houses like Dublin City Council, and you have multiply that by 7 units within each house, if you go that far, or if it is done, it's a lot of units to go around and manage. But by the end of this presentation, hopefully I'll have introduced something that we are bringing to the market, or have brought parts of it to the market, in relation to trying to overcome that in compliance with the guidelines and the regulations. That's basically just to cover the landlord area itself. Again, certification for the design, installation, and commissioning of smoke and heat alarms within the dwelling itself. That's there. Again, it's a cert that's been more widely used now than it was before, and guys are more used to using it and want to use it. I suppose from an electrical contractor installation point of view, they feel a bit peeved because they now have to design the system more than likely, because the architect or the engineer just puts on the specification as per IS 3218 or grade DLD2. So it's left up to these guys to design systems. So there's more inquiries coming in. There's more of these guys want to be educated in relation to the proper installations and all that. And that's exactly what we're doing with our training sessions, going around to all these contractors. I think we have about 1,500 contractors trained at the moment in relation to the installation of this. And it is something that's out there. These guys, I suppose, you'll always get the cohort of guys that want to do everything or mostly right. And these are the guys that turn up to our training sessions just to make sure that everything's going right for them. So that's, we're in the middle of that at the minute. Well, not at the moment because of the COVID thing, but as soon as we get released from that, we'll be back out doing our training with our mobile. I presume some of you have probably done some of the training already with us. Okay, so that's the smoke detection side of the business. We'll have a look now at the COs, and we'll run through this in relation to the similar way that we did the smoke detection, where we're looking at Part G of the building regs. We're looking at IS 813 for the gas installations, and again the rented accommodation. So if we look at the regulation, what it says here, reasonable provision shall be made to avoid danger to the health and safety of the occupants of the dwelling caused by the release of carbon monoxide from heat-producing appliances. Again, we have to delve into the document to see exactly what they're talking about here. So where a new or replacement open fluid or fluidless combustion appliance not designed solely for cooking purposes is installed in a dwelling, a carbon monoxide alarm should be provided, A, in the room where the appliance is located, and B, you get an option here, either inside each bedroom or within 5 meters, that's 16 feet in old money, of a bedroom door measured along the path of the corridor. And that's important from that point of view. So there's 2 locations. So if you have just one heating source within the house, you have 2 alarms. If you have 2 heating sources within the house, you have 3 alarms, and so on and so forth. And one has to be in the location of the appliance, and the other has to be within 5 meters of any bedroom. So if we look here at 1521, and where a system chimney is being used with any heat producing appliance, and the flue passes within or over a habitable room, and that's whether encased or not, then a CO alarm should be fitted in that room. Okay, the definition from the Department of the System Chimney is it's manufactured off-site and assembled on-site. They're not talking about a standard traditional chimney breast that's going through a bedroom. They're not talking about that. They're talking about a system chimney. So it's manufactured off-site and assembled on-site. So it's bits and pieces put on top of each other and put together. That type of system that they're talking about in there. But I suppose practically what has really happened is people covering their own backside, I suppose, is they're some of them are putting in carbon monoxide alarms in bedrooms anyway. Not required if it's not a system chimney. Okay. Okay, there it has to comply with the 50291, which is the standard for the manufacturing of the carbon monoxide alarms. It has to incorporate a visual and audible indicator of end of life. And the manufacturer should have third-party certification. And we have all that from the BSI is our third-party certifier on that. And that hasn't been interrupted by Brexit. They have moved, or they've opened premises in Holland, and they do all their testing from there. So we're compliant still under the BSI for the EN standards. The power sources for carbon monoxide alarm. Unlike the smoke detection side of the business, where for new builds, major refurbs and rewires, you have to have mains with battery backup. For carbon monoxide, you don't. The power sources for carbon monoxide can be replaceable battery, they can be sealed for life battery, they can be mains with battery backup. The only unit that's not allowed under the standard is a plug-in unit. And that's not allowed because of the location of the devices. If you have to put a carbon monoxide alarm on the ceiling, you wouldn't have a socket in the ceiling to take that, and if you did, it may fall out anyway. So it's the only unit that's not allowed is the plug-in type. Okay, for the gas installations, if you look at the right-hand side of the screen here, you see a gas boiler on the side. You'll see the elbow, and you'll see the bit that goes through the cavity and out on an external wall. If you look at that from a gas installation point of view, if that is in a room on an external wall, you do not require a carbon monoxide alarm within that room unless it's a bedroom. And that's from an amendment that was in 2017. So if that's a gas installation with just a boiler like that on an external wall with the elbow, with the bit going through the cavity, then that doesn't require a carbon monoxide alarm in that room. But again, practicalities have seen that guys are putting in carbon monoxide alarms in those rooms anyway. But it's not there under the standard. Where it does come into play is if you extend onto that flue. So where the extended flue is concealed within a duct or a void, inspection hatches shall be provided to permit the inspection of flues throughout its entire length. And a Type A carbon monoxide alarm complying with the requirements of Annex I shall be installed within each duct or void and interlinked to shut down the appliance. It's the only time you'll see interconnection of carbon monoxide alarms as well in the standards. There's no requirement in Part J. There is in IS 813, and that is interconnected to shut down the appliance. So it has to be connected to a relay device or other types of devices to shut down the appliance. Okay, so the carbon monoxide detector complying with the requirements of Annex I shall be installed in every room to which the flue or duct passes, and in any room where the duct or flue passes through the ceiling space. So if we look at this graphic here, and we see the boiler on the right-hand side, you have an extension of the boiler up to on a vertical flue, goes into an elbow, and then it goes horizontally across two rooms and out onto an external wall. A lot of people say that that's unusual. It's not that unusual. It happens quite a bit, especially in apartment blocks. And we've done a lot of work in these situations over the past number of years. So what we're looking at here, if you see this graphic and you get what's in it, I think you've got the what they're trying to do in 813 in relation to carbon monoxide detection. So you have a boiler that's brought into a kitchen or a utility room, and then you have the extended flue off that. So in duct or void that the flue is passing through, you have what they call two Type A devices. Type A device, carbon monoxide alarm, is a device that detects carbon monoxide, it sounds, and it also sends a signal to another device to activate. So what has happened here is those two devices that are in, because that's not an open ducted void all the way through, it's segmented. So we need one in each segment. But both of those devices are connected to the relay alongside the boiler. So if any of those activate, they will send a signal to the relay and that shuts off the boiler. Okay, so they're your type A devices. Within each room that duct or void passes through, you have to put a type B device. And the type B device is defined as a carbon monoxide alarm. It detects carbon monoxide, it sounds, and that's it. It doesn't do anything else. It's a standalone unit. And if you look at the room where the appliance is in there, on the right-hand side, it's on the ceiling. And if you look at the room on the left, room 2, it's on the wall at breathing level. And we'll go through that in the location of the devices in a second. Okay. So these are the amendments. Only one CO detector now required when fitting a gas cooker, gas hob, or gas oven. Prior to this, you needed one within 5 meters of any bedroom door, but they've done away with that, and it's just one device now. Plug-in units, again, are not permitted, and it's recommended that a CO detector be fitted in where a room-sealed appliance is located in the bedroom. And we went through that at the first slide on the carbon monoxide or the gas installation. So you have SI 70 or 137 as they call it now, and it's for rented accommodation. This is very straightforward, unlike the smoke detection side of it, or unlike Part J. It says there's nothing about no replacement here. It says where open fluid or fluidless appliances, it's like wood burning stoves, the gas boilers. It requires the provision of a carbon monoxide alarm in the room where the appliance is located, and either inside each bedroom or within 5 meters of any bedroom door. But the only difference there is that I suppose it's not no replacement. It's if the appliance is in there, you fit a carbon monoxide alarm in the room where the appliance is and within 5 meters of any bedroom door minimum. Okay, so that's carbon monoxide. Just to show you, I suppose I'll go through a few things in relation to technologies that are out there. AudioLink has been around for a couple of years, and I don't know whether a lot of you are familiar with it or not, but it's widely used. Some local authorities, housing associations won't use carbon monoxide alarms unless the AudioLink feature is built into the device itself. So I suppose the background to AudioLink comes from the carbon monoxide side of the business, where it's such a sinister gas you can't see, smell, or taste it. So you don't know if it's around the place or not. Unlike smoke detection, you'll know if you have a fire, you'll know if it's a false alarm. But with carbon monoxide, you don't. So I suppose from an investigation point of view, to set up a test for carbon monoxide to see whether carbon monoxide present in an atmosphere, it takes hours. It's a very expensive process. But with AudioLink, you just download the information from the device itself. You have an app on your smartphone, and it gives you the information. We just go through how that happens. So the data can be extracted by any contractor or anybody with a smartphone. The extraction can be done on site. It's a close proximity download, basically. It saves time for contractors on site. The data can be extracted multiple times. So for the life of the unit, you can do it as many times as you want. And it's a comprehensive data for your records. So basically what happens is on step 1, you press the test button 3 times on the unit. You have your app open on your smartphone. The alarm then will emit a number of beeps. It's like Morse code, basically. So it's basically what we use is we use the sound that's already in the unit to transfer the sound, the information through sound waves. Okay, so it's a kind of a simple old technology. The sound is already there, so it's a handy mechanism to get the data out, and it's transferred. That data is transferred through the sound waves up to the microphone on your smartphone, and the app then will convert that into a readable format. So that's the format that you get. We just have a look at it in a bit more detail and see exactly what data you can extract from that. The age, which is the runtime of the unit, it's the time the unit has been on the ceiling. The battery level, the battery status of the unit. The sensor status, we monitor for open and short circuits within the sensor itself. Then you got your peak level of carbon monoxide if it was present. So it gives you the ppms of carbon monoxide up to a level of 999. Just go through the 3 digits. Again, in the next section of it, you'll see the test button activations. I mean, that's something, again, housing associations, local authorities, property management companies love this because there is a certain onus on the tenant to maintain the device itself. So you have to test it on a regular basis, as we went through earlier on. And also in the next section, you can see if the device has been removed off the ceiling. And that's very important, especially from carbon monoxide point of view, because if somebody is removing off the ceiling, we've seen this on numerous occasions, if somebody is removing a carbon monoxide off the ceiling because of nuisance alarms, that's very, very dangerous because, as we said, you can't see, smell, or taste carbon monoxide. If it is present, you could be in serious danger. The next section is we clock up the amount of high, medium, or low levels of activations that have been had, and we give the last event days. So you can see there from that, you had a high CO event, which is over 150 parts per million. You had 3 of those, and the last event was 5.7 days ago. We do plus or minus 4 hours on this because we don't have a clock within the unit itself. That's the parameters that we work off of. We also have a barcode reader within the devices, or a barcode scanner within the device itself, within the app, and that can read the unique serial number of each of the devices. So that gives, I suppose, context to the data that you're downloading to the device. So if it's changed from any different location within the house, that can be followed as well for the life of the unit. So if you see there, right hand side where it says scan, that's the unique serial number of the device. It's located in the kitchen, so you can write in the location of it within the house itself, who the landlord is, what town or the address of the premises, and the unique property number, whether you use that or not, or some local authorities will, and they have their own systems for doing that. So they can all be recorded, and you can send that as an email to whoever requires it. So the maintenance guy going into this house can download that information, send it off to the relevant local authority, housing association, or property management company, and whoever is looking at that, and they'll have it as a record. And this is basically just what you get on a report. So you can see from here, we have one carbon monoxide alarm, which is the top one, and underneath that we have some of the 650i 10-year battery operated smoke alarms. So we've had an activation or a low battery in one of the carbon monoxide alarm on that. It's just something that was highlighted just to put it on the report show. But again, it's done on what we call the traffic light system. So if it's all green, everything is good to go. If it's red, you have an issue, or if it's amber, you need somebody to call out to the place because there's a maintenance issue. So that's a full report. As you can see there, there's 6 units, so there's 6 units within that house, and they're all associated with the one address. So that's the audio app. We also have a lot of what I've spoken about here in this section. We have a new app that's out there, and I would advise anybody, if you're interested in this, go to your app store, whether that's with iOS or with Android, and go to your app store and download this. It gives you an awful lot of information. It does exactly what we have the graphics on it for the location of the devices and the different types of devices for within the house itself. You can create this, and it also gives you links to the our website, which will give you links to training videos we have for house coding and installation side, and also for standards and regulations. We have links to those back to the website as well. So it's a very, very useful app from the point of view of the smoke detection. That's a new app that's just released. So if you just go to EI Alarm Selector in your app store, you'll be able to download that free of charge. Go back a second just to show this on video. No, it's not coming up. But it is something I would recommend. Again, as I said, it gives you all the graphics, and once you put your finger on the house and the particular room, it will tell you the devices that are required under the IS329 standard. Okay. SmartLink, new technology again that's come out recently, and again we have a gateway. This is the Internet of Things, where things are moving from our perspective. So this is the SmartLink gateway that's associated with this system. We have some of these on test at the minute with some local authorities and housing associations out there, and the reaction has been very, very positive. In the UK, we have just under, I think, 20,000 of these devices installed at the minute with on average 5 units off each device. So it's a thing that's moving fairly rapidly. So it's an alarms system information obtained remotely. It's mains powered. It's a fixed installation. It's managed on a desktop or a dashboard. It's a cloud-based solution. We use a roaming SIM, so we're not depending on people's broadband or anything else within the tenant's house or apartment. And it's an easy setup using a smartphone or a tablet. So if you look at the SmartLink itself, every unit within the system requires an RF interconnection. So if it's a mains powered unit, it has an RF module in it. If it's a 10-year battery operated unit, it has to have an RF module in it. Or we can't download any information from a hardwired interconnect system. We have to do it through RF. The RF is sent, that information is sent to the gateway. And the gateway then, as we said earlier, has a roaming SIM. And that SIM will transfer that information to a cloud-based solution. And you can read that information from your desktop on your portal. Again, that's just an installation with all RF devices connected to the gateway. We use our unique protocol for the interconnection of those devices. There's also a unique serial number within each of the devices that we manufacture. We have multi-level messages depending on what you require. And it's a true mesh multiple path interconnection of the RF. So we don't foresee any, I suppose, disconnection of the interconnection of the devices within the system itself. So that's our cloud-based portal. We send the information from the gateway, as I say, through your SIM card onto your portal through a GSM multi-network. We get a heartbeat from that gateway every 12 hours. Obviously, if anything happens in the meantime, you get an automatic message from the gateway to your portal, and all that information is encrypted. So the gateway itself, it's a phone app supported install. It's a very, very simple way of installing the system. So we have your smoke detectors on the left-hand side, or your carbon monoxide or your heat detectors. Your gateway is installed, and during your commissioning stage, you use your smartphone to install and commission the system, and that sends all the information then through the gateway up to the portal. We do this on the scanner within the app itself, or the SmartLink app. We scan the QR codes, which give all the information, the unique serial numbers of each of the devices and the modules, and that's all sent and to your portal as well. So it gives you individualized information in relation to each individual apartment. So what information can you get? If you look at the SmartLink side of the business, it's all the new 3000 series, so top of the range rechargeable battery backup. 3000 series devices gives you top of the range information. The old 160 series are still available, or not available for purchase, but they're still out there in the field. So they are capable of sending certain level of messages to the portal. Our 10-year battery operated units are RadioLink Plus, and they send a certain level of information also. And the RadioLink devices, then you have our accessories, which can be put on the system, but don't give any information at the moment. And that's being worked on for the next level. So if you look at the SmartLink, and all the information that's sent out, you get fire alarm, you get CO activations, head removal, button test when the units are powered up and when the event is stopped. That's all for the RadioLink and SmartLink, RadioLink Plus and SmartLink. For the SmartLink side of it, then you get all the faults. You get a sensor fault, low battery fault, end of life, and mains absent. You don't get that with the RadioLink Plus. And for the gateway, then you get a gateway check-in, you get the gateway low battery, and the mains absent if it is absent from the device itself. Again, the gateway has rechargeable battery backup on that, and that will last for in the region of 2 months battery backup. This is your dashboard. On the left-hand side, the green circle on the left-hand side, you can see there is the amount of systems that are installed. So that's the amount of gateways that are installed. And on the right-hand side, you can see the amount of devices that are hanging off those systems that are installed. Immediate action is on the red on the left-hand side. That would give you whether the unit has gone into alarm or not. It's not a first responder. Just be very careful on that. It's not a first responder. You do the very same as you normally do in relation to fire detection or whatever it is. It's just giving you information. You can see trends and it gives you management, I suppose, over your assets in relation to fire detection within the premises itself. The middle section there and the heavy gray is maintenance priorities. So head removed or anything like that will come up. And on the right-hand side then is end of life, dust, or whatever the story is. So you can see this. So again, no matter what your housing stock is, if that's 5,000 housing stock with 7 units on each of those housing stock, that's 35,000 units. You'll be able to manage that from one dashboard and see exactly what's going on. So this is a message that you get on your phone if you have one text or email messages. So you get the error type or whatever has happened, the address of the property, the location of the property itself, the unique serial number of that device, the date and timestamp that the event has happened, the model number that has given the activation, and the description of the fault. So if you just look there, it's head removed, detected at UPRN, which is the training room 11 in Ei Electronics. The serial number was such a number. It's on the 9th of December 2019 at 14:38. The unit is a 3016, and it's been removed off its mounting bit. So that's the detail of the level of detail that goes into relation to the message that you do get. Okay, it's basically designed. This system is basically designed for social and private landlords. So we're looking at, again, local authorities, housing association, property management companies is what we're looking at here in relation to that. And what does it give them? So the top 5 things, I suppose, or 6 things is increased tenant safety, compliance with SI 137. Again, we spoke about that earlier in relation to the unit is in good working order and within its end of life. The asset management of all your fire detection and your carbon monoxide detection within your housing stock. Real-time notifications if you require that. Reactive maintenance. And also risk awareness. So if you have tenants that are fairly high risk or they're on a regular basis have a lot of issues, then that gives you more information about the tenant that's in those establishments. That's, I suppose, that's gone through the first gateway information that we have in relation to I suppose, Rev 1. Rev 2 is coming out in the not too distant future. Again, we have a lot of prototypes and beta sites in the UK running these. We acquired a company in the UK there last year, Homelink. We're very much into data analytics, that type of stuff. So we're moving in this direction in relation to, I suppose, the overall health of either a house or an apartment or whatever. So with the sensors we have at the minute, we have the optical, the carbon, the heat, and the multi-sensors. And where we're moving to is on the environmental side. So we're looking at carbon dioxide, we're looking at humidity, we're looking at information coming from the boilers, efficiency of boilers, efficiency of the apartments or the houses themselves in relation to heat leakage and all that kind of stuff, and fuel poverty from the tenant's point of view. So these are all the areas we're looking at. Again, we're looking at phase 2 of the gateway. Will be coming out with this information. Again, this is a cloud-based solution, and we get all that information out to the cloud. And again, a dashboard will be used for gathering that information as well and access to it. So if we look at, again, what we're looking at here is proactive repairs, I suppose, in the apartments or the premises itself. The efficiency of the investment that's made, if you're looking at insulation and all the other types of stuff that happen. Preventative maintenance, we're looking at safety and well-being of the tenants, we're looking at the carbon emissions, and we're looking at compliance of SI 137. So we're looking at prevention through prediction, basically, is what we're looking at here. So we can identify reported and unreported problems with mold, report a smoke alarm that has been tampered with. We can also highlight the long-term unexpected property vacancies, if that occurs. And we can identify homes with poor thermal ratings for potential investment into doing installation and that type of stuff. So we've identified a lot, I suppose, over the last couple of years since these systems came out in the gateway, especially for areas where tenants have removed the devices off the ceilings and that type of stuff, and not replacing them, so leaving themselves vulnerable within those premises. So the example platform, I suppose, where you have all your sensors. We have a boiler there, so we're getting information from some boiler manufacturers that want to tie into this system as well, give feedback in relation to the efficiency of the boiler, If it's not working efficiently, then it needs a service, and all this type of information can be gathered and sent back to the dashboard and that. So there's it has an independent connection again. We're not using the Wi-Fi within the premises, the tenant's Wi-Fi. We're using our own GSM system. Again, it's the open protocol system, the open source protocol in the SIM card. Back to the dashboard, and again, your information can be seen on your smartphone if that's required. So I suppose there's nothing more important than a good, safe, secure, and healthy home. I'd just like to thank you for listening. I hope I wasn't too much over the time, and I hope it was of interest. So if I see there's a couple of questions in.
Okay.
We'll answer all these anyway.
Thank you very much, Tom, and I'm conscious of the time. So can you see the questions there, Tom? Yeah?
Not at the minute, no.
Okay.
Can I just come in there for a second? We're kind of gone over time, and I think what's the best thing to do is we don't have much time to kind of answer them now live, but what I will do is I'll upload the questions and answers underneath the description on the YouTube video. Perfect. If that's okay with you, Tom, I'll forward you on the questions, and then you can give me back the answers, and I'll put it up on the YouTube video.
Perfect. That's perfect. Yep.
That's great. Thanks, Tom.
Okay. Thanks very much for that. Can you stop your share screen there, Tom, please?
Yeah.
So thanks again to, just bear with me. So just to let you know, thanks again, Tom, for a very informative presentation. And as my colleague, and thanks again, Shirley organised this event. So thanks again for the assistance, Shirley. And Tom will answer your questions and we'll circulate it through YouTube. Just upcoming events that we're proposing to have on February the 25th. WAVN Ireland will be doing the Part H presentation, again, similar format, 12 to 1. March the 11th is a heat pump domestic installation. That's to be confirmed. March the 25th, Gyprock, the product supplier there, is going to do an event for us. And then we have the roof membranes manufacturer there on April the 1st. April the 15th, we'll be doing domestic electrical installations workshop. And May the 13th will be the senior architect from the department will be talking about the Built Heritage Policy, and we will have ongoing events. And note that the live events will be circulated with Eventbrite, and some events might be recorded, and we will circulate them on the NBCO YouTube. So I'd just like, again, to thank Tom. That's the website for Tom and contact details. And there are contact details there, support@nbco.gov.ie. And our website is localgov.ie. And keep an eye on our Twitter, YouTube, and Eventbrite if you follow us or subscribe to us. And thanks again for everyone attending.